Welcome back to all the Form 4 and Form 5 students. Today I will focus on one question on coordinate geometry. This is a good quality question for you to prepare for hot question. Okay? Normally for hot question, they will give you a diagram. Normally they give you a picture, a diagram to stimulate you to think based on the diagram. So, step 1, understand the question first. Now, in the diagram on the right, radius AB, highlight of the Ferris wheel is a circle, is perpendicular to the tangent of the circle at point B, 812. Okay, highlight. The equation of the tangent to the circle at point B, equation of the tangent, very important keywords. At point B is given 3x plus 2y equal to 48. Equation of the tangent is given. Find the equation of the radius. Okay, find the equation of the radius of the Ferris wheel. So, based on the property of the circle, radius and tangent always perpendicular. Okay, this is a very basic skills that you must know. So that means at the point B, okay, that line passes through point B. The yellow line is called as tangent to the circle, and the B is the contact point that meets the radius. The radius now is in red color. Okay, and tangent and radius always perpendicular, means they are making a right angle or 90 degree. Okay, so when there is perpendicular, the gradient for the radius multiplied by the gradient of the tangent to the circle must be equal to -1. This is another important concept that you must know. So the blue and the red line, okay, making right angle at the point B. Okay, so now the yellow line and the red line, which is radius, okay, making right angle at the point B. So we call as perpendicular. Alright, so now we need to understand that perpendicular means 90 degree. So I label 90 degree with a green color. Okay, that is right angle, to show to you that radius and tangent always perpendicular. So let's say the radius is having gradient m1. Okay, m1. So the gradient of the tangent to the circle is having gradient m2. Okay, so both of the line are having different gradient, and when you take the gradient of m1 multiply by m2, you will get -1. So we say the product of the gradient is equal to -1. Since the equation of tangent is given, which is in yellow color, but the equation is not in gradient form, so you cannot read the gradient. So your first step is you have to modify your equation until you can write them in gradient form. Gradient form means the y must be equal to mx plus c. Okay, so we need to rearrange the equation. Okay, we have to shift the 3x to the right. Okay, then we have to make sure finally we simplify until y equal to mx plus c. So we start now. Do y equal to negative 3x plus 48. Because the 3x is from left, so shift to the right, you have to change the sign. And we want 1y, so there is a 2, so we divide by 2 every term. So once you have the y equal to m is the number itself is the gradient, x plus c is 48. So obviously from the gradient form of the equation, you can read the gradient directly from the equation of the straight line when it is in gradient form. Okay, now we have the gradient for the tangent, which is negative 3/2. Okay, that is the gradient for the yellow line, equation of tangent. Okay, now I use a purple line to show that the gradient for the M2 is negative 3/2. Alright, so based on the concept of M1, M2 multiply is equal to negative 1, the product of the two gradient is equal to negative 1 when they are perpendicular. So hence we can substitute into the M2, then we can find the M1. Okay, so the M1 is a gradient for the radius, so it's unknown, so we write M1 times M2. M2 we have just now we have negative 3/2, right? Okay, so from the equation that you modified just now, you got gradient of the equation of tangent is negative 3/2. So from there we can substitute and we can find our gradient for M1. So M1 times negative 3/2 equal to negative 1. So you have both sides negative, so you cancel out the negative, become positive, and the 2 you just times to the other side and divide by 3. So it means that you are obtaining the gradient from the relationship between the perpendicular line. Okay, so M1 now is 2/3. Now in order to form the equation, you need to make sure, okay, you have gradient and the point. After you got gradient and the point, you can substitute into the equation y equal to mx plus c, right? Then you will get the new c, and hence you will write the new equation. Okay, again I highlight to you, the M2 is the equation of tangent, then the M1 is the equation of the radius. Okay, so they are making the right angle at the point B. So the gradient for the equation of tangent is negative 3/2. Okay, we find the gradient from the equation given. We express in gradient form. Y equal to mx plus c. Then we solve the m, then we can get the other m. Okay, so for question like this, is actually very common in exam nowadays. So you must understand that the concept of the circle is radius and tangent always making 90 degree, or we call as perpendicular. Okay, so now I'm going to show you how to solve the gradient first. So how to solve the gradient, I'm doing it again. This is the second time so that you can follow it well. Express y equal to mx plus c. So your gradient is negative 3 over 2. So then, based on the gradient for the tangent, you can find the gradient for the radius by using relationship between m1 times m2 equal to negative 1. Okay, this is because both lines are perpendicular. So the gradient for the AB can be found using the relationship between m1 and m2. When multiply, you get negative 1. So again, I'm showing you that I need to express into y equal to mx plus c. Then only I can read out the gradient. So the gradient for the tangent to the circle is negative 3 over 2. So now we are going to find the m2. So if gradient of tangent is positive, then the radius will be negative. If gradient of tangent is negative, then the gradient of radius will be positive. So it's always opposite sign. Okay, and then we want to find the gradient for the radius. As I say just now, we just substitute into the equation, or some of you can figure out very fast, which is 2 over 3. Okay, good. Once you got the gradient for the straight line, you have to find a point that lies on the straight line. Then only you can use the point and the straight line to find the C. Then after you find the C, you have to rewrite again your equation. Then only you will substitute the 8 and 12 to get the C. We'll use these two information to form the equation of the straight line. Okay, there are two methods to find the equation of tangent. The most easy one is y equal to mx plus c. Okay, or you can use y minus y1 equal to mx minus x1. But I think you're used to this max method, so no harm, you can continue the same way.